Got a new system. I got these two equations. So what if I don't want to graph? Because I don't want to graph that. Look at that. That does not look like it's going to be nice to graph. And this one, I can't use substitution either because this one I would have to solve for y, and I don't want to do that either. Well, I guess that leaves us with elimination. But these aren't in standard form, or at least the second one's not. The first one's okay. So how can we change the second one to make it in standard form? Well, for standard form, the x has to be on the other side, so let's start with moving it over there. Minus 6x here, minus 6x over here. Now I've got a negative 6x minus y equal to a positive 4. Now that is standard form. I can work with that. So I've got this one and this one now as my system. Same exact thing. Well, can I use elimination here? Well, not quite, because that's a negative 6 and a negative 6. I need a positive and a negative with the same coefficient. So let's go through. You stay there for a second. Let's multiply this entire thing by a negative 1, so we can have a positive 6 and a negative 6, so we can eliminate the x. Multiply this whole thing by, let's put it over here. Negative 1, that means this number, this y, and this x. All three of these need to be multiplied by that negative 1. So, negative 6 times negative 1 is a positive 6. Negative y times a negative 1 is going to be a positive y. Oops, I almost forgot the x. X, positive y, equals positive 4 times negative 1 is a negative 4. Now I have two equations that are, we'll write that a little bit more on the sides. 6x plus y equals a negative 4. Very nice. Look at that. We have now we have a system where we can actually use elimination, positive and negative, which means, how have you been writing this? Have you been just writing it like this?
Just go. You got this. Perfect.
Okay, I'm just making sure. I want to be consistent. Okay, so from here, x is eliminated. We've got 1y minus 5y, so we're going to have a negative 4y equals negative 4 plus 20 is going to be a positive 16. So let's go ahead and solve for y. We've got our coefficient. We can divide both sides by a negative 4. Y and a negative 4 is our answer. Excellent. Now we've got one of them already. We've got y is equal to a negative 4, but we're not done yet. We still need the other answer. So let's just pick one of the equations to go ahead and plug the y in. We're going to take, let's do this one. So we're going to do negative, instead of the y, I'm going to replace it with a negative 4, equals 6x plus 4. There you go. We're going to go ahead and solve this for x so we can get the other part of our point. All right. Oh, look at that. This is going to be positive 4. 6x plus 4. Get rid of our constant by adding, or subtracting. 0, 6x, divide by our coefficient to get this variable by itself. X here is actually equal to 0. Excellent. Well, now I've got my 2, so I'm done, right? No, we still need our answer as an ordered pair. Remember the x comma y, so I've got 0, comma, negative 4. Now we've got our answer. So sometimes we need to rearrange the equation first, then use some elimination. All right, go ahead and pause this one and try on your own. Okay, so the first one right there, you may notice is not in standard form. It's almost in standard form, but not quite. Notice the x comes second. So let's reorder this one using the commutative property of addition, which means I can just order this to be 3x plus 4y equals an 18, because they're both positive. So using that and this one as my system, excellent. So can I use elimination now? Well, not quite. We've still got two positive 4s. One of those is going to have to be negative. So let's do that. Let's turn this entire thing, multiply it by a negative 1, here, here, and here. Remember, all terms need to be multiplied by that negative 1. So negative 3x minus 4y equals a negative 18. Now it looks like we can actually use elimination for this system, because we've got a positive 4 and a negative 4, so those are going to cancel out really nice and neat. So, negative 2x plus 4y equals 8. Okay. These two cancel out. We've got negative 3x plus a negative 2x, which is going to be a negative 5x, equals negative 18 plus 18 is going to be a negative 10. Excellent. One-step equation. Divide by negative 5, divide by negative 5, and we end up with very little room. X equals a positive 2. All right, one down, one to go. Let's pick, doesn't really matter, I'm just going to pick the first one. 4y equals, 4y plus, my bad, 3 instead of x, I'm going to put this 2, because this x is what I am substituting in here, equals 18. Excellent. Let's go ahead and solve this one for what? 3 times 2 is 6, so that's an easy simplification to make. 18. This is just a two-step equation. So subtract 6. Ooh. 4y equals 12. Divide both sides by that 4. Get rid of our coefficient, and we've got y equals a 3. All right, once again, we are not done just yet. We've got both of the numbers, but we still need to put it as a point. So that means our answer is going to be an ordered pair. 2, 3. Nice, not too bad. All right, once again, pause or try on your own. And let's go. So for this one, we need both of them in standard form. We've got x equals a thing. So let's go ahead and move that negative 5y over to the other side. Come here, you. So plus 5y and plus 5y here. Now remember, standard form has x first, so I'm going to put x plus 5y equals a negative 11. Excellent. We can work with that. So notice here we've got an x plus 5y equals negative 11, and up here we have a negative 2x minus 5y equals 11. We already have something we can eliminate. Those 5s, we've got a positive and negative. Perfect. Come here, you. Let's just reorganize a little bit. All right. This is our system that we are working with. We've got the 5y and the negative 5y. Those two are going to cancel. X plus a negative 2x is going to be a negative x equals negative 11 plus 12 is going to be a positive 1. Excellent. Now remember, this is a negative 1 as our coefficient here. So divide by negative 1, divide by negative 1. X equals a negative 1. Nice. Halfway there once again. I'm going to pick probably that one. So instead of the x, let's change the color. Instead of the x, I'm going to substitute in my negative 1 to solve for y. So negative 1 equals negative 5y minus 11. Very nice. This is already a two-step equation. How convenient for us. All right, solve here. Get rid of the constant. I need a 0 pair. Add 11. Add 11. Negative 1 plus 11 is going to be that positive 10 and a negative 5y over here. Get rid of the coefficient. Divide by negative 5. Divide by negative 5. Negative 2 is equal to y. Nice. Done, right? No, stop thinking we're done. We still need the actual ordered pair. Parentheses with a comma in the middle. X is a negative 1. Y is a negative 2. Now we're done. All right, last one. Go ahead and pause it.
I don't want to do that one.
Why not?
I don't know.
Last one. Pause it. Try it on your own. Mr. Craig doesn't want to do it, but we're going to do it anyways. Okay, did you do it? I hope you actually tried this one on your own. You better have. Okay, first of all, if we want to solve this by elimination, we're going to need standard form. Ow, hit my finger. Anyway, we're going to need standard form. That first one is the one that's not in standard form. So let's move the x over. Whoop. Add x here, but like I said the last time, standard form has x first, so I'm going to put x plus a 2y and a negative 2. Excellent. We're partway there. Comparing it to the other one, well, these two coefficients are both positive, so we're going to want to multiply that by a negative 1 while we're here. Multiply that. Gotta stop writing so close to the edge. By a negative 1, here, here, and here. Again, all three terms need to be multiplied by this negative 1. So I've got a negative x minus 2y, and then equals a positive 2. Negative times a negative. Nice. Okay. Now we've got a system that we can work with. This we can do elimination with. All right. Negative 2 and the positive 2 are going to be the one that cancels out, so the y's are gone. For the x, we've got negative x plus the 4x, we've got 3x. 0y, so we don't need it. And then 2 plus a negative 17, we got negative 15. Nice. Divide both sides by our coefficient, positive 3. X is going to equal a negative 5. And we're almost there. Next up, let's take that first one, because that first one actually already has y on one side by itself. It looks like it might be a little bit easier for us. So we're going to substitute in this negative 5 for the x. We're not substituting it in for the negative x. Be very careful with this. So we've got a 2y equals the negative number. Now instead of x, I'm going to put the negative 5. Yes, it's okay that there's two negatives. We'll survive. All right, let's go ahead and simplify. Negative 1 times the negative 5 is going to be a positive 5 minus 2. 5 minus 2 is just 3. Now, this 2y is still here. It's still going to come along with it. So all we got left, don't need that. All we got left is this. There we go. We can divide by our coefficient. Turns into a 1. Y equals a 3 over 2.
Whoa.
Ah, fractions?
I
What?
see it. It's not a perfect answer.
Oh no, what are we going to do? Well, we're going to leave it as a fraction. That's all we're going to do. That's our answer. If we want to turn it into a decimal, we can. Technically speaking, this is also 1.5. Either answer is correct though, but it's not correct if you stop here. This isn't our answer. Our answer still needs to be an ordered pair. So we've got the negative 5 for x, and for y, I'm going to use that 3 halves. There you are. See, that wasn't so bad. Fractions are not that scary.